right, welcome. Today we are looking at different ways that we can display data. We are going to do a quick review of a frequency table and a line plot, and then we will talk about histograms and stem and leaf plots. So remember, a frequency table is a table that summarizes a set of data by showing how often each data point or category occurs. So it's basically keeping track of how many times each response happens. And then the line plot is a graph that displays data along a number line using dots or X's to kind of show your data points. Now, in class, we would go through and collect our data about our first letters in our letters in our first name. Since I'm doing this kind of just as an example, let's just say that we had that this was our data from our class. So then what we would do is we would make our number line, and so I would start with just 1, 2, 3, 4, 6, 7, 8, 9, and 10. And now I'm just making a dot for each of these data points. So first thing I'm going to do is I'm going to find the frequency of each one. So for 1, we had 0. For 2, we had 0. For 3, we had 3. For 4, we had 7. For 5, we had 3. For 6, we had 2. For 7, we had 1. And for 9, we had 2. Now I'm just going to make those dots. So above the 3, I need to make 3 dots for our 3 data points. And then for 4, I'm going to make 7. I would say the main thing that makes line plots a little bit more difficult is that you want to try and get the spacing of your dots equal, so that way when you're comparing, you can kind of see what lines up and what doesn't more easily. Because for example, if I took the 3 here and they were more spread out and the 3 here that they were more squished, it might not look, or I might not catch that they're actually the same number of data points. And then the nice thing about line plots is it kind of helps visualize the spread of our data, because we can look and see that most of our data is grouped right here, and then we kind of spread out this way. So that's the example of a line plot. All right, so a histogram is a graph that uses bars that show the number of values in each interval. So that's probably the main thing with histograms, is that they are looking at intervals of data. And with histograms, you will usually see that the bars are touching. So what we're going to do here is we have some examples of some cross-country race times for 2 miles. And we are going to organize the data and then show it in a histogram. So to help show it in the histogram, the first thing we're going to do is we're going to put it in a frequency table. So we're going to have our time, and then I'm going to do tallies, and then we'll have a frequency of how often. So I have to decide what kind of interval I want to look at. Since this is doing times and it looks fairly spread out, I'm going to do my intervals by minutes. So I can see that my smallest time or my lowest time is 14:02. So my smallest interval is going to be the 14, and then we're going to go all the way to 14.99. And then my next interval would start at 15 and then go to 15.99. And you'll notice here that we have that 1 second kind of gap. So basically this is going to include anything that's under 15, and then our next interval would start with 15. So we have 16 to 16.99, 17 to 17.99, 18 to 99, And then there was one in the 19, so we're going to go all the way from 19 to 1999. And I'm just going to start tallying. So 1645 would be here, 1425, 1840, 1603, 1512, 1915, all right. Now, if we wanted to, we could have made some of our tallies even closer. So if we found that our data was too spread out, we could even maybe sit and put like these two together, and these two together, depending on how much we want to kind of spread out our data and see where the individual data points last or are. So I'm going to set up my histogram. So this is going to be our 2 mile times. And then speaking of that, I forgot to label up here. So this would be like letters in first names, because we do want to title our graph. Right? And then what we would do is basically I'm going to make those same intervals. So I have the 14 to 1499, 15 to 1599, 16 to 1699. I'm sorry about my sloppy handwriting. 17 to 1799, 18 to 1899, and then we have 19 to 1999. And then I have 1, 2, 3, 4, 5. So this would be our times, and then this would be our number of runners at that time. Okay, so since 14 to 1499 is 2, we would show that bar with 2, and we might, shade it in with a color. And then 15 to 1599 was also 2. Maybe I'll use a different color. Oops. To show that time. And then 16 to 1699 was 3, so it's going to come up. Oops. 1. Make that a little bit better. 17 to 1799 was also 3. And then we had 1 and 1. And I ran out of colors, so I'm just going to kind of reuse. So this would be an example of a histogram. And then, like I said, you can see that the bars are touching because since they're covering intervals, they are touching. So unless an interval did not occur at all, your bars would be touching the entire way as you kind of go through. And then this is just, histograms are nice when you have a bunch of data that falls within different ranges, and it's almost too much to put into like a line graph because there's too many like differences between points. This is a nice way to kind of group data and make it easier to read. All right, our last way to display data that we're going to talk about are stem and leaf plots. These are typically new, and students have not seen these before. And honestly, it's a nice way to display data, but you don't necessarily always see them a ton in real life examples that I know of. But a stem and leaf plot is just a way to plot data points where values are split into what we call stems and leaves, where the leaves are the last digit only. So what it's going to look like, so here we have an example of some basketball scores that some points that George scored in his last 15 basketball games. So, so we're going to label it George's points. And what it looks like is I'm just going to make almost like a tree. So it's this line. And then in our tree, on the left side are going to be our stems, and that's going to be the first digit of these numbers, but it's one digit for any of them that have like 2s in them, so it's kind of a combination of histogram and line plot in a way. So we're going to start with 0 as our stem, and then we're going to go 1, 2, 3, 4, 5, and I'm going to stop at 5. And then with the stem and leaf plot, we're always going to include a key. It's going to tell us what it means. So in this case, this means 23 points. Now the challenge of the stem and leaf plot is we have to also put the data in order, like we would for a median. So first thing I'm going to do is I'm going to go ahead and find all of my data points that are single numbers. So that we would have a stem of 0, and that's 7 and 8. So now when I write them, my leaves would look like this. And the way we would read this is the stem is 0, the leaf is 7, so this would be a data point of 7, and then this would be a data point of 8. Now I'm going to find all of my numbers that have a 1 for its first digit. So that would be 14, 19, 11, 15, and 15, and 15. So as we look through those, 11 is my smallest, so that's going to be my first stem. Then it would be 14, and kind of like with the line plots, we want to try and spread it out so that, oops, I missed one, there's a 19, so that the data points are equally spread. So I did 14, and now we have 15 3 times, so I'm going to show 15, 15, 15, and then we have 2 19s, so it's going to be a 9 and a 9. All right, so I want you to pause the video and see if you can complete the rest for the 2s and the 3s. All right, so I'm going to start with my 2s, so we have 23, 24, 20, 21, and 27. As I look through those, 20 is my smallest, so that's going to be my first one. Then I have a 21, a 23, a 24, and as you can see, I'm trying to make them equally spaced, and then a 27, so that they're kind of lined up with my leaves from my previous one, so we can see that this leaf is 2 shorter than here. And then lastly, we only have the 32 left, so that would be our stem. So it's kind of a combination of different things, which makes it nice. It's kind of like a line plot because you can see the individual data points. It's kind of like a bar graph because if you turn it on the side, you can kind of see the length, and kind of in a way like a histogram because you're doing ranges of numbers together, unlike a line plot where you would have those individual data points. So like I said, just another way to look and organize our data.